So this is the very last property of logarithms we're going to look at. It's called the change of base formula sometimes for logarithms. Sometimes that's what people call change of base formula, or the change of base property for logarithms. So let's say you have three numbers, a, b, and x. A and b are not 1. A and b are not 1. A, b, and x are all positive. A and b are not 1. And I can take the log base b of x and rewrite it as the log base a of x divided by the log base a of b. So, just for example, if I wanted to approximate, for example, the log base 13 of 16, there's really no way to figure this out analytically using the properties that we have. This doesn't come out to a nice answer. So everything I've given you in the past came out to a really nice answer when you were evaluating logs. I made them like that so they come out nice. But this one wouldn't come out nice. There wouldn't be a nice way to find this analytically. So you probably have to use a calculator to approximate this. Now the problem is most calculators don't have a log base 13 in them. So most calculators just have the log. Most calculators have just these two, most calculators. They just have the log, which we understand to be log base 10. And they also have the natural log, which we know is log base e. Those are the only logarithmic base functions that most calculators have. If I'm going to, let's see, the Google calculator, this is an online calculator, you can see right here, zoom in, there are only two that they have as well, the natural log and the ordinary log, which is log base 10. So log base e and log base 10 are the only ones they have. So the question is, well, how would you calculate something? How would you calculate something if it's not base e or if it's not base 10? Like in our problem, how do you calculate the log base 13 of 16? Well, use the change of base formula. So my instructions here are use change of base to rewrite and then approximate and calculator. So I'm going to use the change of base formula. So the change of base formula says I'm going to take, this is my x right here, the green one, and the b is my 13. So what I can do, I can change the base to any base I want. I can change to any base a that I want as long as it's a positive number that's not 1. So you can change this to base 10 or the base e. So that's what we're going to do. We're basically going to change this to just ordinary log of 16 divided by the log of 13. Now, why did I change it to ordinary log base 10? Because you can do that in your calculator, right? You can take log base 10 in your calculator. So let's do that in our calculator. I'm going to pull out this calculator here. So how would I do that? I would take, zoom in, log of 16. How do you type 16? There you go. Close parenthesis, and then divide by, you have to close the parenthesis, log of 13. And that'll give me about 1.08 for an answer. So we're going to approximate that. That's about 1.08. I'm taking it to the hundredths place, to 2 decimal places. So you could do it that way, or you could change to natural log. It doesn't matter what the base is. You could also do it as natural log of your top here, 16, divided by the natural log of your logarithmic base 13. You can do it that way as well, and you'll get the same answer. It doesn't matter whether you're using log base 10, log base e, log base whatever. It'll all come out to be the same based on this property. So let's plug this into our calculator just to see. So this time I'm going to clear this out. So this time I'm going to use the natural log, right? The natural log rather than the regular log. So natural log of what? 16 divided by the natural log of 13. And we should get the same number, about 1.08. See, 1.08. So it doesn't matter however you use it. You're going to still get a 1.08, approximately. Those are really easy formula to use. Okay, let's just do one more example. So let's say I wanted to do the log base 9 of 1/2. So I'm calling this bottom number my red number. That's my logarithmic base, and my argument, 1/2, is going to be green. So what you can do, you can change the base. You can write this as log, just ordinary log, right? That's just base 10. Log base your initial argument divided by log of your original logarithmic base 9. So plug that in a calculator. Let's do that just so we get practice. Clear this out. So I'm going to do log of 1/2 okay, close parentheses, that's the log of 1/2 divided by log of 9 equals, and you get about minus 0.32. Okay, let's do that in the other way where we use the natural log, just to see that you can do it this way as well. So in this way, we do the natural log of 1/2 and then divided by the natural log of 9. So we're doing a different logarithmic base, right? We're doing base E. Let's just see how it works in the calculator. So I'm doing natural log of 1/2, 1 divided by 2, close parentheses, divided by the natural log of